Hello. Software-defined everything is the data center buzzword of the year. But what does it mean and where's it going? I spoke to a range of industry experts to find out. We've heard a lot over the years about the benefits of virtualization technology, but what are its weaknesses? Where is it overhyped?
I can't think actually necessarily of weaknesses of virtualization, but certainly virtualization technologies need to be applied where it makes sense, and then they need to be applied properly. Certainly not every application out there is suited for virtualization, but then also when you apply virtualization, you should do it in a way where you're still keeping a tab on the hardware so that ultimately you still have an ability to troubleshoot if problems were to occur.
You can argue overhyped or not. The two classical weaknesses with virtualization technology is chain of trust. So if you have a container or a virtual machine, how do you tie the authenticity of that virtual machine back to something that's well known and physical? And how do you tie the physical node that virtual machine is operating on up to the virtual machine? So you create a chain of trust. You know, in the old days where I would physically image a server and run an application on it, it was super clear because that server was in a locked cage and I could identify it very specifically, and that has become very ephemeral. Another weakness you can argue that Moore's Law continues to help us against is that when you're running these virtualized technologies, there is some layer of inefficiency to what you could achieve by a full-fledged server. With that said, you know, we work with a lot of customers that are in high-performance computing environments, and many of them are opting to effectively ignore that inefficiency, recognizing that they can scale out their applications. It's typical in today's modern data center that your application is much bigger than the size of one machine, so you're building a distributed application anyways, so scaling is a kind of a natural byproduct.
A lot of the hype has mostly been cleared away. So I don't think it's as overhyped as it used to be. I also think that now many customers understand where its value is and where it can be deployed, and they're not apt to get crazy and get into situations where it really isn't a good fit.
Drilling down into specific virtualization technologies such as software-defined storage and so on, which do you see as being most successful and why?
SDN gets used a lot more than people think. It just gets done in very innocuous ways and somewhat manual. There's not a huge vendor base around it. You're not seeing people make a lot of money because if you look at the underpinnings of SDN, network virtualization and network function virtualization, big acronyms that hopefully people know what they are, what you find is that the tools to do that exist on most networking equipment, and much of the applications or network functions you might want to package exist in a virtual form. So people are able to put it together by themselves without needing a supplier to do it for them. SD-WAN has been super efficient and effective to people, taking advantage of the capacity afforded by today's internet to stitch up what used to be a hardline circuit between 2 points, but doing it in an ephemeral and super malleable way.
I actually think it's hard to pick a winner about which one of these technologies will be best. I think it will be more important to see is where does SD, software-defined technologies, make a big difference for each one of these applications. I see them as unique applications: storage, compute, networking, and WAN. I think for that reason, each one of those will have unique use cases that will be successful. I think you can't compare them all because they'll all be used in certain ways that really make a big benefit. I think what will definitely kind of shift or change is that the use cases will become more dominant in number. So you'll see a few number of very successful implementations, and then you'll see less of the hundreds of experiments or proof of concepts that happen. So just like in software-defined storage, I think software-defined is a little more mature right now versus SD-WAN and the WAN environment where there's still a little bit of hype cycle left. There's not a lot of adoption yet, and customers are just starting to learn about SD-WAN as a service. So there's a lot to wash out, both implementations, vendors, technologies, and a lot to learn there. 2 years from now, SD-WAN will be more mature, less hype, less misuse of the term and the technology, whereas something like software-defined storage is pretty established now.
Organizations are buying into software-defined storage and moving to software-defined data centers. But is that good? Is it bad?
It's actually very good because it gives them a level of abstraction. Software-defined is all about policies. You define the policies, and the underlying infrastructure just goes and implements the policy or provides the mechanism. And by making this distinction between policy and mechanism, you can get way more level of abstraction. You can kind of move around the underlying infrastructure. You can move to the cloud, back to the data center. That's what software-defined gives to you.
I mean, there is no alternative to operating data centers, whether it's the storage, the compute, or the network, through software. So to me, it's not about whether software will operate data centers. I think there is no question that that is required in order to deliver on the agility that's required by the business. The question is much more that of execution. What software, how to architect it, how to design it in a way that it indeed meets the requirements of those businesses.
Yeah, software-defined data centers are super powerful, and you can kind of you can articulate software-defined data centers in multiple layers. At the most fundamental layer, it really is, I'm going to buy a piece of hardware that has, a silicon, storage, whatever's necessary to do its job with no operating software in it. I'm going to image that device to take on a personality. So we have a financial customer that's a phenomenal example of software-defined data center. They have a unit of compute, which is 9 racks and about 270 servers, super high performance network, a bunch of disks inside, and they buy those from a bunch of system IT suppliers. That rolls into their data center. They completely image every device, the storage nodes, the server nodes, the network nodes, as part of their automation toolkit. And they deploy it with one of 3 different personalities, like an OpenStack or virtual machine type personality, a container personality, and a big data personality. And so with that level of flexibility, they can put in business capacity in an incredibly fast way and an incredibly predictable way. Everybody that utilizes one of those units of compute knows how it behaves and what to expect out of it. Phenomenally powerful for them.
We've heard a lot about software-defined everything, but is that really the future? And why might it not be?
Well, it is the future. The only reason I can think that it might not be is because some legacy applications kind of don't fit well with the new software-defined data center. And these applications are also changing, but that's the only reason I can think of.
The funniest part is software-defined everything requires really cool hardware to make the software do something interesting, right? Software by itself is vaporware, right? It does nothing. And so, the advent that software, rules everything, I think is slightly flawed. Software is taking advantage of phenomenally awesome advancements in hardware, and so we can never really lose sight in that today.
I think in general, there will be a software-defined element in just about every service that's out there for enterprise services. I would just say it can't be used as a whitewash, like some firms have done, as abusing the term software-defined, which has been done very frequently, unfortunately, in the last 5 years. I think what's going to happen is you're going to see more of exactly where it fits or doesn't fit, exactly where software-defined network does work, and I think you'll see clarity that there may be a minority, a real small minority of the cases where software-defined architectures and technology either won't work or won't create the benefit of certain situations. I think there will be some cases, for example, and I'm talking single-digit percentages, where it just makes more sense to keep things in hardware. And so whether it's a specialized application that creates a certain ASIC, there's going to be a single-digit percentage where software-defined isn't going to help and/or doesn't provide any benefit. So you'll see unique cases where they still need some hardware that's specific and some ASIC kind of technology that says, you know what, this calculation, this geo large file crunching really belongs somewhere else and not into a software-defined environment.
And where do you see the next advances in the data center? And do they involve virtualization?
Yep, so virtualization was a great way to abstract away from the hardware, but now we have new things, new technologies, microservices, containers. I think that's where probably the next breakthrough is going to come, where components in the data center are going to become very, very fine-grained and very, very lightweight. Now you can, moving a VM is kind of hard, but moving a micro device, like a micro component like a container is very easy. So that's probably where we'll see a bunch of disruption.
Well, all the advances will evolve multiple technologies, right? We're going to see advances certainly on the hardware side, right? We see 25 gig coming in and 100 gig coming in. When we move from photos to videos to virtual reality, the bandwidth needs are going to increase, and these networks have to scale out. And on the software side, right? I think that again, because massive automation is required, we're going to need to build out all those layers of software that will control every aspect of operating a data center. So certainly, very exciting times ahead.
I think the biggest breakthroughs are going to be around optical interconnect and memory technology. If you look at the performance, the capacity, and the cost of memory technology, it's reasonably good right now. But when you look at where the industry would like it to be, there's still a big discrepancy. And physicists are very smart people and very creative, and I think they're going to start applying their brains to it, or not, they're going to continue to apply their brains to it and come up with some amazing advancements there.
I actually think one of the biggest breakthroughs is going to be the expansion of the technology to go beyond the data center. So I think there's a lot of work going on between data centers, between cloud data centers, between private and public data centers. A lot of talk about multi-cloud, hybrid implementations. I think one of the big breakthroughs is going to be when people realize that these technology implementations actually can expand way beyond the data center. So I think of the large carriers, for example, who tend to realize that they start using this in a data center or a major node, and then they realize the value if they could put it across the rural node, the metro node, and then all the way to the edge.
So virtualization is here and looks set to march on for the foreseeable future.